So here we discuss the solutions of this assignment one.
Sorry, sir, I forgot to mention my ID number.
Okay, but keep in mind from next. Okay, this is not only for you; it is for everyone because many are there who are not writing IDs there. So you should write ID from the next assignment there. So assignment one solution. Question number one. Let I show you the question one first. There is only find find the real root of this cubic equation using a bisection method correct to 3 decimal places, and hence find the negative root of this equation. Okay, this is the something different thing that we are not discussed in the theory class. Okay, so we'll come to that also. First of all, we have this cubic equation, and it is checked f of 0 negative, f of 1 negative, f of 2 negative, and f of 3 is positive. That is good thing. Okay, so this thing you should mention. Only one thing you can write it here. Hence the root lies in the interval 2 comma 3. Okay, that is missing, so you should start with that. Hence the root lies between the interval 2 and 3. Now the iteration started. So he started n equal to say 1 first iteration, a is 2, b is 3, and then just a plus b upon 2 is the iteration formula, and it is mainly focuses on the sign. The if magnitude is not written, that is also okay, and if you return, that is also okay. It doesn't matter there. Okay, so f of xn is a negative. So as it is a negative, it should replace to the a, because f of a is negative and f of xn is also negative, and that way it is continued. And he got after 11 iteration, it is observed that first 3 decimals start repeating. So 2.706, 2.706, and you'll observe, yes, that's a correct answer. It is correct to the 3 decimal places, and 2.706, that is only the answer he received. Now I will tell you the variation. Few of the student got this answer probably in 10th iteration or 9th iteration. That's okay, but you can't say that I got to correct up to 3 decimal places in 3 or 4 iteration only. If you are getting the answer in 3 and 4 iteration, it's not possible, because Newton-Raphson method is only the method who give the answer in these less number of iteration there. So here 7-8 iterations generally we require minimum, and depending on how many decimals you are considering, whether you are doing round up or you are not doing round up, that also affects to number of iteration. So choice is your, but the answer will be near about unique. Like here 2.706 is the answer he written. Someone written suppose 2.705 or 2.708, that is also okay there. Okay, so these answers are considered correct. Now to get a negative root. Okay, so here I'm surprising that you are getting these answers very good. This is just like your self study you done. If we have alpha is a root of fx minus alpha is a root of f of minus x, that is a property. So this property, if you know, then you can quickly write the answer. See, the property says that if alpha, if this alpha, if this alpha is a root of fx minus alpha is a root of f of minus x. So this is the property that we are using to get the root of that other equation. And you will observe that other equation is just f of minus x. If you replace x to the minus x, whatever the second equation we given, that is f of minus x, this one. So the root of this equation, f of minus x, this is not correct. This is not f of minus alpha. F of minus alpha should be 0. Are you getting? This should not be written f of minus alpha here. Okay, so f of minus, see, f of minus x is this polynomial. Now root of this f of minus x is minus alpha, that you should write. Got it? Only there is a small correction at the end. So instead of f of minus alpha, you should say minus alpha is equal to this one is the root of that f of minus x. Any doubt, anyone in the question one?
No, sir.
No doubt.
No, sir.
Okay. So only the last line is not correct. Otherwise, everything is correct there. So question number 2 then. Question 2 is again a bisection method we have to use to get a root of sin x equal to 1 by x. And
excuse me, sir.
Yes.
Sir, in question number 1, there are two different equations.
They are not different equations.
Sir, there it is -9 and there it is +9.
So I'm saying this is f of x and this is f of minus x. Uh, Are you getting?
So sir, there it should be plus 4x then.
No, you check. See, let I show you. You have to write the equation fx equal to 0 and f of minus x equal to 0, and then you can check it. Okay, so I will show you here. This is our fx. I'm saying. Okay, just a minute. So this is fx. Okay, so I will take f of minus x equal to, this is fx equal to 0. Now we have to write f of minus x equal to 0. Just replace x by minus x everywhere. So minus x cube is a minus of x cube, is it? Then
Yes.
minus minus plus 4x, got it? And that minus 9 as it is. Now this equation and this equation is the same because it is equal to the 0. Just if you take minus 1 and merge that minus on the right side, you get x cube minus 4x plus 9 equal to 0. Are you getting?
Okay.
So
Sir, can we do it separately by using this equation?
why you are going to do the 9 or 10 iteration again? Your question is already given na, hence find the negative root. Hence का मतलब है using this. Okay.
Okay.
So when we said this alpha is the root of this fx minus alpha, that is minus 2.706 will be the root of this equation. That is the direct answer. It is in one line answer. Yes.
Okay, sir.
We
Got it.
can do
Thank
with
you.
the property, that's fine, but can we find with another method the roots, because it's not mentioning here like you have to use bisection for second question. Like,
No. The question is straightforward. It is written hence find. Hence का मतलब है using that way only. Are you getting?
okay, sir.
Okay. Otherwise, yes, there are multiple ways. You can go by Newton-Raphson. You can go by okay, hit and trial. Number of ways are there, but you should understand the question first. In the question itself, it is written hence find. Okay, that's all. Come to the question 2 now. The best part of the question 2 is we are given everything. First of all, we are given the interval. The interval is 1 to 1.5. Stopping criteria also given. We have to do the 7 stages, that is 7 iteration. And you'll observe trigonometric term appeared in the equation. That equation can be considered as x sine x minus 1. That is our fx. Fx is x sine x minus 1. That is the fx. And trigonometric term appeared there. Hence, we should do the calculation in radian mode only. And the answer is here 1.11328. Let me see whether I done correctly or not. So question number 2, 1 to 1.5, this is already given. Just you have to check whether f of 1 is negative, f of 1.5 is positive. Yes, the root exists there in between. And after near about 7 iteration, you got 1.1132. Okay, and that's correct answer there. Got it? So this is just a table here. But remember, this formula writing is very important here. If you forget to write the formula and just return the answers there, it's not good. So formula is also important. You should mention there. That about question 2. If anyone have a doubt in the question 2, yes, you can ask. So come to the question number 3 then. Use a false position method to find a real root of this equation. I think this question we done in the class, is it? We already done
Yes, sir.
this question in the class, and that is correct up to 4 decimal places. So fx is x log x minus 1.2, and yes, okay, this question we done by Newton-Raphson method actually, but here we have, this question is by a false position method. So for false position method, let me see how it completed. So x log x, yes, x log x minus 1.2. So xn is a f of b minus b f of a upon f of b minus f of a. See, he checked f of 1. F of 1 comes a negative. F of 2 comes a negative. But f of 3 is a positive. Okay. Now we have to use a log tab from the calculator because it is a base 10 for calculation purpose. And as f of 2 negative, f of 3 positive, a, b are taken as a 2 and 3. And then they use the formula that a f of b minus b f of a upon f of b minus f of a. Here you will observe after 4 iteration, the answer comes correct up to the 4 decimal places, which is 2.7406. 2.7406. That's correct. Good, very good. And this is the way you should write in the final exam also. Only the thing that is missing everywhere, that nowhere mentioned in which interval the root exists. So here one line is required, that you should say, thus the root lies between the interval 2 and 3. That's one. And the last question then, last fourth question of the tutorial, use a false position method to get a fourth root of 32. Yes, few of the student have the doubt before how to write the equation, but yes, we discussed that in the class also. As fx is we want as x equal to 32 raised to 1 by 4, so it is x4 minus 32 is a 0. F of 0, f of 1, f of 2, f of 3, but f of 2 is negative, f of 3 is positive, root exists in 2 and 3, and then the iteration proceeded, and you got the answer as 2.377. I think that's the correct answer. Yeah, 2.377, that is the answer. Good. Any doubt, anyone, in the any of the question of the assignment 1?